Consider two conducting coils having arbitrary shapes placed near each other. The coils may also have an arbitrary inclination with respect to each other. Suppose that the coil 1 has N1 turns and coil 2 has N2 turns. Now when a current I1 is passed through the coil 1, some of the magnetic flux generated by the coil 1 will be linked with the coil 2. From the Biot-Savart's law that the flux Phi2 linked with the coil 2 will be proportional to the current in the coil 1. Therefore Phi2 is proportional to I1. Therefore Phi2 is equal to M21 into I1. When the current I1 in the first coil changes, there will be a corresponding change in the flux Phi2 linked with the other coil. From Faraday's law, it follows that an induced EMF will be produced in coil 2, which is given by epsilon 2 is equal to minus d Phi2 upon dt. That is equal to minus d upon dt into M21 into I1. Therefore epsilon 2 is equal to minus M21 into di1 upon dt. The constant of proportionality M21, which appears in the equations, is termed as the mutual inductance of the system formed by two coils. Taking I1 is equal to 1 unit in the equation, Phi2 is equal to M21. So one can define the mutual inductance of the system formed by the two coils as the amount of flux linked with the other coil when a unit current passes through one of the coils, is termed as the mutual inductance of the system formed by two coils. If the current is expressed in amperes and the flux in Webers, then the unit of mutual inductance is Weber upon ampere is equal to Henry. If one takes di1 upon dt is equal to 1 unit in the equation, epsilon 2 is equal to minus M21, then one can define mutual inductance of a system of two coils as the EMF generated in one of the coils due to a unit rate of change of current in the other coil, is termed as the mutual inductance of the system formed by two coils. If we take di1 upon dt in ampere per second and epsilon 2 in volts, then the unit for mutual inductance becomes volt second upon ampere is equal to Henry H. The value of mutual inductance of a system of two coils depends upon their sizes, shapes, the number of turns, the distance between them, their mutual inclination angle, and the material on which they are wound. We could as well have considered the current to be flowing in the coil 2 and its induction effects on coil 1. Such a consideration shows that the value obtained from mutual inductance is the same. That is, M21 is equal to M12 is equal to M.